A law firm has 4 partners: a senior partner, P sub 1 with 4 votes, and 3 junior partners, P sub 2 through P sub 4, with 1 vote each. The quota is 2/3 of the votes. This law firm operates as the weighted voting system. Open bracket 5:4,1,1,1, close bracket. Complete A through C below. First off, we'll start with part A. How many sequential coalitions is the senior partner P sub 1 the pivotal player? Hint: note that P sub 1 is the pivotal player in all sequential coalitions except those in which he is the first player. Now, when we talk about those where he's the first player, this first position, this is P sub 1 and he is the first player. And if we go ahead and understand how many coalitions there are, since there are 4 players, we will use 4 factorial. And 4 factorial will be equal to 4 times 3 times 2 times 1, which is equal to 24. That is the total number of coalitions. But even so, we are only concerned with the coalitions where, or the number where P sub 1 is the pivotal player. That means that P sub 1 cannot be in the first position in the coalitions. So we're going to use the following: n factorial minus n minus 1 factorial. And since there are going to be 4 players, n is equal to 4, and n minus 1 will be equal to 3. And now we simply find n factorial, which means we have 4 factorial, and we're going to subtract from that 3 factorial, and 4 factorial is 24, and we're subtracting from that 3 factorial, which is 6, and that means that this will be equal to 18. So that you will fill in 18 here, and you will have the senior partner P sub 1 as the pivotal player in 18 coalitions. Now parts B and C talk about using the answer in A to find the Shapley-Shubik power index of the senior partner P sub 1, and that means that we are looking for omega sub 1. And we also want to find omega sub 1, omega sub 2, and omega sub 3, and omega sub 4, which are the power distribution numbers for this particular Shapley-Shubik power distribution. Now, there are some complex calculations that go along with this, but instead I'm going to show you how to use a Java applet contained in my math lab. The first thing that you're going to do is go ahead and bring up my math lab. Once you've brought up my math lab and you are at this main screen, you will then left click on multimedia library. Then that's going to bring up a whole new screen, and we're going to have a number of different options once the screen comes up, and we'll see that we have Java applets here, and we want to left click find now. And you'll notice that there are a number of Java applets, but I am interested in the Shapley-Shubik power index. So left click that, and that will bring up a pop-up window. Now, if you do not have Java enabled, you will need to do so. If you are using Chrome, such as I am right now, please be aware that Java and Adobe will no longer be supported sometime after December. In addition, you would use Firefox for the most part because Java tends to run fairly well in Firefox. Make sure that you have enabled all your security protocols so that you can use Java. I do have a Java video that shows how to go ahead and enable that to run. Well, now that we've brought up the Shapley-Shubik index, I want to go back to the original screen that I was looking at, which is this one. And I need to remember to use this particular power distribution. 5 is going to be the quota. So hopefully you can see this. This is going to be the pop-up that comes up once you have enabled your Java applet and you have clicked on this. There is a lot of instructions here, and I would definitely recommend reading these instructions. So you go ahead and read all this right here, and I'm going to run through the problem really quickly. So go ahead and left click Shapley-Shubik index. Now, in order to do this properly, we need to make sure that we have the number of players represented. Notice that there is only one row here, and we need a total of 4 because there are 4 players. So we're going to add 1, 2, 3 rows. Notice that this is player 1, player 2, player 3, player 4. And now we're going to type in the weight or distribution. You just go ahead and type in for P sub 1 a 4. And then for the rest we'll type in a 1. And it doesn't matter if there's a 0 in front of it, because when you click into another field it will go away. And then we'll type in a 1 right here, and we'll click over here. Now all 4 of these weights are locked in with each corresponding partner or player. So we will go ahead and type in the quota down here, which in this particular case happens to be 5, and then we will left click compute. And this gives me the pivotal count of 18,222, which adds up to 24, and the Shapley-Shubik power percentage or indices means that for player 1, 75% is the corresponding value, and then 8.33% is a corresponding value for player sub 2, player sub 3, and player sub 4. You will need to convert these into fractions, because when you look very carefully it says type an integer or a simplified fraction. It's okay if you don't know exactly what they are, but when I look at this right here, the Shapley-Shubik power index, the first one that I'm going to be dealing with, which is this right here, that's the 75%, which I can just type as a fraction of 3/4, and that's what I would type in right here. And now you'll notice that I have a total here of 24, and that this 18 for the pivotal count, well, when I do 18 over 24, that is equal to the following. And this will reduce down to 3/4. And so when we reduce this, we end up with 3/4. And that is what, as I showed you, is what we type in right here. Now, we want to use the answer in B to find the Shapley-Shubik power distribution. And that's in this law firm. We already know that this one is 3/4 because we calculated that one. This one says type integers or simplified fractions, and I am going to use the Java applet that we have talked about. Notice that there are a count of 2 right there. And then that's going to be over 24. So that will be 1/12. Okay, and that's what you're going to type in right here. And since the weight of all 3 of these are exactly the same, okay, exactly the same, these are going to be 1/12 also.